Where am I on my cheat sheet?
Chair,
I should properly introduce you.
Chair, I should just note that with Director Koch's departure, we no longer have a quorum, so this is informational presentation, no longer an open meeting, no longer.
Okay. Thank you, Noah, for bringing that point up. I'm still looking forward to the presentation, but it is with a lack of a quorum at this point.
And we're not seeking any board action today, so this is
pretty much informational, and will be
informational update.
Informational update, which more to come over the next few weeks in terms of board action and board information. So again, Executive Director of Commuter Rail, Mike Muller, and Senior Director of Rail Modernization, Alistair Sawyers, here to present an update on the Fairmount Line Emission Project Agreement. Welcome.
Good afternoon, Chair McGee, members of the board. I acknowledge the late hour, so I will be as brief as I can while still providing the necessary update. So quick overview of the presentation for this afternoon. We're going to go over the benefits of battery electric multiple unit train sets. This is a review of some information that had previously been presented to the board over a year ago at the start of this program, but now it's become more real that we actually have a selected manufacturer and a proposed design that we're going to talk about today, and want to highlight the benefits of battery electric multiple unit trains. Again, we will talk about the selected manufacturer, the selected financier, and the procurement process to get there. We'll talk a bit about the proposed contract framework, the estimated project timeline, which is a significant update today, and then end with a small update on the supporting project infrastructure, sort of the other things needed to deliver this program beyond the vehicle. So the benefits of battery electric multiple unit train sets. These are very different vehicles than the traditional commuter rail, regional rail, push-pull train sets where a locomotive powered by diesel in our system, someday powered by battery electric technology, pull non-powered coaches. These are 4-car bi-level train sets. They are self-propelled vehicles, sort of coupled together in a way you don't break up the train sets the way that we do with the locomotives and the coaches and have mixed consists. These 4-car consists stay together all the time and operate as one vehicle, essentially. They operated up to the 79 miles an hour maximum authorized speed we currently have on our system using onboard traction, battery power, but also drawing power from overhead catenary systems. Some of the benefits are that these trains are much quieter than what we're used to in our current commuter rail system with the diesel locomotives. They significantly reduce noise and vibration, not just for passengers on board the train, but for residents and abutters to tracks and facilities and stations. And then, of course, these vehicles are fully compliant with all modern safety and crash worthiness regulations. The use of battery electric multiple unit trains in lieu of the current commuter rail rolling stock will enable 20-minute frequencies on the Fairmount line in both directions, with the future possibility of increasing that further to trains every 15 minutes in both directions. And in addition, where we have additional ridership capacity needs, if we see that on this line or at some point in the future on other lines where these may be expanded, we can couple 2 of the 4-car consists together to make an 8-car BEMU train set. And then, interestingly, we have both high-level and low-level doors for the potential for future expansion to other lines without all accessible platforms. The Fairmount line, of course, which is the first place where we're going to introduce these vehicles and operate them in the near term, has all accessible platforms. There are 2 stations that have mini high platforms and low level platforms on the Fairmount line, but the majority of stations have full high level platforms. So if you look at this rendering here, you can see right away that we're talking about a very different look and feel of a vehicle. This is a more modernized feel. This is very different than the interior of a commuter rail coach as we currently know it. You can see the bucket seating rather than the bench seating. It's 2 by 2 rather than the 2 by 3 bench seating currently featured. And there will be modernized passenger information systems and passenger counting systems as well. The accessibility features are an important element, which I'm going to discuss a little bit more on another slide, but per the MBTA's own accessibility requirements, there are ADA accessible seating areas in each of the 3 passenger cars for each BEMU train set, and a fully accessible restroom, one accessible restroom in one car of each train set. Another benefit has to do with infrastructure savings. So because of the use of the battery technology in conjunction with the pantograph that draws electric power from the catenary, we have the ability to actually reduce the amount of infrastructure needed to provide this decarbonized service. If this were an electric train or an electric multiple unit train, we would be required to have overhead catenary wires for the full length of the line. In this instance, on the Fairmount line, which is less than 10 miles long and already has electric catenary infrastructure at both ends, at South Station and at Reedville, where the line connects with the Northeast Corridor, we actually have no need for any additional catenary to be implemented to operate these trains. So,
Mike, could you just explain that a little bit so people understand?
Absolutely. So, with electric-powered trains, the power actually comes from the overhead wires, and the train or the vehicle, and this, we operate Silver Line buses that take electric power from overhead wires as well using a pantograph. Okay, thank you. These vehicles have batteries so that they can operate on a battery where there is no overhead catenary, and they operate using the catenary at strategic locations where we do have the charging infrastructure to take power. So in a situation where we expanded this to another line in the future, we would need to add electric infrastructure to those lines. The Providence line, of course, already has electrification infrastructure, and I came to this board a couple of months ago and talked about a procurement for battery electric locomotives, which in the same way will use the overhead catenary wires on the Providence line to operate, but can operate in locations without the power infrastructure using a battery for traction power. And this is a Buy America compliant vehicle manufactured in the United States. So the way that the procurement process worked, just a brief review of this, we released a request for information in August of 2024 to the industry for the manufacture of battery electric train sets. We then followed that up with a request for proposals, an RFP, in January of 2025. And then we subsequently issued a second RFP for the financing of the vehicles for an operating lease. So we've procured a manufacturer and a financier. The way that this arrangement will work is that the financier will actually purchase the vehicles from the manufacturer and then lease them to Keolis and the MBTA. So on to the selected or proposed recommended awardees. For the BEMU manufacturer, Stadler US Incorporated is recommended as the proposed manufacturer of the BEMUs. If the contract is approved at a subsequent board meeting, the Stadler would manufacture 7 of these 4-car BEMUs with options for up to another 96 cars for potential future expansion as future funding and electrification infrastructure becomes available. And the contract would also involve a technical support and spare supply services agreement known in the industry as a TSSA for a minimum of 5 years and a maximum of 15 years. And this is about training and upskilling of the existing mechanical maintenance workforce, because this is a completely different kind of technology than anything that we're maintaining today. So the workforce will have the benefit of the tools, the spare supply, and then also the training and the technical expertise provided by the manufacturer for up to 15 years if needed. But the people actually turning the wrench, doing the maintenance work, are our existing mechanical maintenance forces. For the financial contract for the purchase and then lease of these vehicles to the MBTA, we've selected and recommended Rock Rail Holdings Limited. This is a company that has experience doing operating leases of rolling stocks elsewhere in the United States, elsewhere in the world, although this is not a common practice in the United States. Again, the agreement structure here is that Rock Rail, the financier, and Keolis, acting on behalf of the MBTA, purchased the BEMUs from the manufacturer Stadler. Keolis and Rock Rail enter into a 15-year lease to finance the manufacture of the vehicles. There will be a direct agreement between the MBTA and the financier Rock Rail, which will require the MBTA to ensure that this operator, Keolis, transfers the lease to each successor operator for the full 15 years of the term. As you're aware, we're in the middle of a successor commuter rail contract procurement now. So whoever the selected future operator maintainer of the commuter rail system is will take over these agreements, even if that entity happens to be the MBTA in the event of any future insourcing of the service. Keolis and Stadler will enter into the TSSA agreement that I just described for mechanical maintenance support services of the vehicles. Again, the current commuter rail operating agreement is expiring in June of 2027, so all of these agreements must transfer over to successor operators and or the MBTA. And MBTA and Keolis will also enter into a direct agreement to assure that these agreements transfer. So we are still in an active commercial negotiation with the parties, with the selected manufacturer and the selected financier. So while I don't have final numbers to share, they'll be shared in a subsequent meeting where we're actually seeking a board vote on these contracts. We do have some indication from the proposal and from the ongoing discussions that there have been some estimated cost increases since the last time the board was briefed. And just the general areas where we're seeing the cost increases, of course, there's inflation. The prior price projections, which were done by MBTA staff, were in 2023 prices, and we have seen some inflation since that time. In addition, although this is a Buy America compliant vehicle that will be built in the United States, some of the key components will be sourced from overseas, and therefore there are some additional costs projected related to tariffs. In terms of the scope, and I'll talk about this on the next slide, during the design review process, the MBTA made some design modifications that added some cost and time to the budget and the schedule. And then the capital maintenance item, what we're talking about here is vehicle overhauls, which is a future capital expense that's not currently in the 5-year CIP cycle. These costs would be in years 9 and 10 of the lease, so way beyond really 2 full CIP cycles out. So this is a capital expense that the MBTA would bear responsibility for, the overhaul of these vehicles that exists outside the CIP and therefore is currently unfunded. But it is a cost that, in full transparency, I want to make sure that everyone's aware of and will be part of the contract that eventually comes before the board for approval. So on to the timeline. This is a pretty significant update in an area that I know board members will have interest in. When we initially presented the program, our own internal projections based on the proposal and the information from the industry about the timeline for manufacture of this type of vehicle was to deliver the vehicles in 2028 for revenue service. During the procurement, the selected proposer actually did propose a vehicle design that was responsive to our requirements and responsive to the RFP that could have been delivered for revenue service in 2028. However, that vehicle design used an accessibility standard that is different than the one that the MBTA uses for this type of vehicle. So we required a stricter accessibility standard, and it essentially requests a design modification to ensure accessible seating in all 3 of the passenger vehicles of these battery electric multiple units. So a little bit more on that. There are two different accessibility standards in the ADA regulations for public transportation vehicles. There's a rapid rail vehicle requirement, which requires essentially 1 car per train. It's actually called in the regulation the 1 car per train rule. For a rapid rail vehicle, only 1 car per train is required to have ADA accessible seating. For a traditional commuter rail coach, the ADA requirement the ADA standard, it requires ADA accessible seating in all passenger coaches, which is what we have today in our system. All of our passenger coaches have ADA accessible seating. Now, these vehicles, of course, are not traditional commuter rail coaches. It's actually more like a bi-level subway car, or more like a rapid transit vehicle. So there are other peer agencies in the industry who have applied the rapid rail standard to ADA accessible seating for this type of vehicle. And that was the standard that was used by the manufacturer to propose this vehicle. For the MBTA, we're choosing the higher standard, mainly because today, on the Fairmount line and elsewhere on the system, but the Fairmount line is really the one we're talking about, customers with disabilities have ADA accessible seating on all coaches on that line today. So changing to a vehicle entirely on that line that reduces the amount of accessible seating on the train to just 1 passenger car instead of all passenger cars would be a step backwards for accessibility that would be unacceptable to us. So the philosophy among the MBTA staff is that it's appropriate actually to apply the commuter rail coach standard for ADA accessible seating, even though this vehicle is arguably not a commuter rail coach. The theory is that if we're moving forward on technology, moving forward on decarbonization, moving forward on service frequency, we're not going backwards on accessibility. So because of the design modification that we made, it increased the timeline, pushed it out to the first car being delivered in 2029 instead of 2028.
I didn't mean to interrupt to that.
Oh, sorry.
That was an important point, but it's funny when you're talking about rapid transit versus commuter rail and whatever, but what we're talking about here is we're purchasing these as potentially up to 96 vehicles, correct?
Correct.
So, which would be running, not really as, I mean, be rapid transit commuter rail, really. And it's kind of a hybrid when you're talking about it, but if you're running to New Bedford or Fall River or to Worcester or whatever, which is in our system, you're really running a commuter rail type car.
Correct.
Right? So when you talk about the difference, and I understand why, because it's quicker, faster, and it's almost like a subway car, but the system that we're bringing these cars onto is not our subway system.
That's right.
You know, the point I'm making is the car we're looking for is something that would be compatible with what's going on in a system that's going potentially up to an hour throughout the system. Just to make a point, it just struck me as you were explaining that there's, even though there's opportunities to go both ways, either or. That,
yes, it's a gray area, and you hit it exactly right, that even if this is more of a rapid transit style vehicle, our system and our service, the way that we operate and the way we would operate on a much longer line than the Fairmount line, it still will be more like a traditional regional rail service rather than rapid transit.
And not to prolong the discussion, but that's in line essentially across all of MBTA modes. When you look at what we're doing with the Green Line Type 10 vehicle, 100% low floor, 100% accessible. So all of our CRRC cars, Orange Line, Red Line, the Blue Line fleet is 100% accessible across all those vehicles. To accelerate a timeline, to take steps backwards in accessibility and access to MBTA service, just to satisfy a timeline in light of all the success we've had recently with the closing of the Daniels-Feingold settlement, it just didn't make sense to accelerate this at the cost of accessibility.
And as you said, it's a step backwards, not a step forward.
It would have been a step backwards for accessibility, but we requested the design modification at the staff level, and that's what extended the timeline. The conclusion that we reached internally in terms of the discussion of our options and alternatives on how to approach this is that we would rather deliver a vehicle that everybody can be proud of and that all of our passengers can use, and that we would feel very good about expanding system-wide in the future, rather than rush to deliver something that we view as substandard, that not all of our passengers could use, and that we, would be inconsistent with our values.
Didn't mean to interrupt. Do you want to continue, Mike?
Thank you. And then finally, I'll just end on an infrastructure update. This is the important stuff that's not the vehicle. This is the unsexy part of the program. We have funding programmed in the existing CIP for facilities and infrastructure that are required to operate these vehicles in service. So first and foremost, we are in design, permitting, and site investigation for a BEMU maintenance facility and charging infrastructure at Reedville Yard. This is existing MBTA property where we currently have an active labor facility and light maintenance facility. That's where the BEMUs will be maintained. The facility that we're building there is a 2-track facility with the potential to be expanded in the future. It includes storage, a power substation, and charging points for the 7 BEMUs. And of course, the future layover site will be Wydett Circle, where those layover tracks will be available after completion of phase 1 of that project. We expect to release a request for proposals for the maintenance facility construction later this year, and we will be bringing the recommended bid to this board for approval. Good news on supporting infrastructure, and I mentioned this a moment ago. Our analysis, our modeling shows that no additional catenary is needed on the Fairmount line in order to operate the battery electric multiple unit trains. Previously, and this is just a couple of years ago, so it tells you how quickly things are changing in the industry, we estimated we would need up to 3 miles of additional catenary on the 10-mile stretch of the Fairmount line. We now know that we don't need any additional catenary, that the battery life is good for 40 to 50 miles, which means with charging infrastructure at both ends of the line, these vehicles can more than capably operate without catenary for the less than 10-mile length of the Fairmount line. In addition, there will be no signal modifications required. The existing signal infrastructure on the line is compatible and workable with these vehicles. The only modifications that we need have to do with some clearance at South Station, both on the platform edge and in terms of the height of the existing overhead catenary wires, which are, the current height is compatible with the low-level Amtrak train sets. These are bi-level cars, so we need to adjust the clearance of the catenary. If you add all that up, all of these investments, the total is between, this is a range because again, we haven't awarded a contract, we don't have 100% design, we don't have bids. So our estimates are between $68 and $84 million for this whole entire infrastructure and maintenance facility program to support the BEMUs. And I would note that the $5 million for track renewal on the line was completed last summer and fall. And so the real total of outstanding costs is $5 million less than that. The range is really $63 million to $79 million. So our plan, that's the update of where we are. Our plan, once the commercial negotiations with the selected financier and vehicle manufacturer are complete and ready for a place to bring to the board, we'll come back to the board possibly as soon as next month to seek approval of the contract.
Great. Thank you, Mike.
I have a question.
Director Butler?
You know I'm going to ask you about the batteries, Mike. You know me, right? So on these train sets, right, every car have a battery in them? Or is it just a locomotive on the front and back? I don't know how
So
that...
there is a battery car that has sort of no passenger seating at all. I believe there are batteries and propulsion systems on each car. Let me bring Alistair up, who's actually more of an expert on the technology here.
So in this particular design, all the batteries are at the It's not a locomotive, it's just a battery unit, which is at the front. The drive goes all through all 4 units.
So it could be in the middle of the train,
It could be somewhere else, but in this design, it happens to be at the front.
so not every car has a battery.
No, in fact, at the moment, none of the passenger cars have it. There's just one non-passenger car that has it. So
Passenger cars have propulsion systems, but not batteries.
batteries. Yeah.
Right, and so we do a 15-year lease, you said, right, on these? If we lease them, we can choose to buy. So if the battery fails, do we pay for that battery, or is there is there a length of time that they're warrantying the batteries?
Yeah, there's a battery warranty. That's how it's structured. And there's a renewal cycle for the batteries as well.
Okay, and on the, the new trains that we're getting, are they heavier or lighter than the old trains? Obviously, a locomotive is going to be
So
heavier, but
it is different, but in terms of the individual weight, even the battery front end piece is lighter than our current HSPs.
so it doesn't mean anything to the tires or the tracks or anything like that, concrete or wooden tires or anything like that, right?
Correct.
'Cause they're
Lower,
light.
in fact, lower wear, yeah.
Right. So has anybody looked at the cost of electricity to like run these?
Yeah, well, actually, this one doesn't have it, but the previous board presentation, we did one based on the then actual electric prices. And as you've heard, while we have a swap currently for our diesel cost, our projected future swap cost next year is significantly higher. So at the moment, we're projecting that there's pretty much a wash between the amount of diesel we're paying now, or will be in the future year in 2030 or 2029, whenever we're sort of running the system, versus the amount of power we're going to have to buy in that year.
So what's going to happen in the summertime, let's just say, right? When it's really hot and everybody's running their AC, where's the electricity coming from? Because you're going to lose, I think, over in Everett, right, with the new soccer stadium, you're losing 2 of the gas-fired turbines over there. So I'm just curious where this electricity comes from.
So that's kind of at the state level, the state energy load. This doesn't move the needle on the state energy load. It's a relatively small need, and it's very efficient.
With the buses as well, really?
Yes, because in the case of, especially of the battery electric multiple units, they have regenerative braking. So the actual need for power is quite limited.
Really?
In terms of kilowatt level, yeah. That will change once we run the whole system electric one day. But at the moment, it's for this single line for 10 miles, it's a highly efficient.
Just on the 10 miles, but if we start advancing, going down to, Providence, like you just talked about, right? And other places, right, then the cost is going to go up, right?
Correct, but it's still not huge, because there is a big difference between having to charge a bus.
I don't see how you can say it's not going to go up, because if you go and charge your electric car, right, you're paying for that car for an hour's charge or whatever you're paying. So how is the cost not going up? You're saying because of diesel fuel?
I just mean compared to diesel. So the projection for diesel is way worse than the projection for electric power.
Just
That's
curious.
just where we're at, yeah.
Yeah, I got you there.
Like this could be cheap.
Director Smart?
Thank you. How long is the renewal cycle for the batteries?
Okay, I'll come back. So we've kind of taken a worst case, so we're looking at, as in the shortest possible, so we're looking at 8 years. That's the current provision. However, a lot of the experience recently with the same kind of chemistries is actually they last a lot longer than that. So it is, we've provided for a worst case, and that's the basis of the warranty, and there's a fund that's built up to pay for that.
Can I ask,
Let's keep on.
how do we get rid of the batteries when they fail? Where do we get rid of them? Where do they go?
So in terms of recycling, a lot of these, they don't fail. What happens is their actual capacity goes below the kind of operational threshold where they're useful, and then they just get used for a different use.
So they're reusing all these batteries, right?
So a lot of them are reused, and some of them are recycled, yeah.
And
Because
how
the
about,
lithium
like,
is so valuable.
cold weather, right?
Yep.
In other areas, I don't know where they're doing them, Mike, or who else has electric trains, but, I mean, what about pushing the snow and all that? No problems, right?
So we have the advantage is it's such a big unit, it's built inside a rail vehicle, so the ability to keep it warm using their own battery, using power. There's a thermal management unit within it. So all these cells, that sort of each individual cell are packaged in a cooling and heating unit that keeps the temperature higher. So it has a much better range than an equivalent car. With cars' issues, around the small unit and the fact you're in a fairly small area and you can't keep that
The only
warm.
reason I'm asking, because I know some of the buses that we have that are electric, that we're having issues with, because on my way in, I just seen a new tow truck, a T tow truck, thank God, we got a new one towing it.
Yep.
So you're seeing more and more of that, but just saying, I know we have problems that we really don't talk about with the
Yep.
electric buses.
No, the buses, it's a much harder use case. They have to patch, you have to find areas in the bus where you can put the cells. It's a lot more challenging on a bus than it is on a train. It's a lot more space on a train, and this particular design is even better because you have that separate unit.
Listen, and I know I'm not against electric, believe me, I'm not. I just, I look at different things, look at Ford, stop making the electric pickup truck, right? There's a reason for that.
Yep. Anyway,
I think Director Butler also, this sort of underscores this conversation why the Fairmount line is a great place to start. A shorter line, a smaller use case, we're talking about 7 trains. We are going to contract for the opportunity for future expansion, but certainly those decisions in the future will be dependent on some of the things we're talking about today and how all this plays out.
Well, and Mike, there's emissions that are, that come off for electric trains and buses, right?
that one is a bit different. So you say the whole life, maybe, if you count the mining at the beginning for the lithium and everything else to create the battery. But in the actual point of use, because of the regenerative braking, it's not like an electric vehicle where there's emissions from the brakes and the tires. It's steel wheel and it's regenerative braking. So, there is a fail-safe sort of conventional brake as well. But you typically pretty much have 0 emissions. That's the beauty of this particular design, yeah.
On the trains.
On the trains, yeah. So it's different from a car or an EV.
And there's no diesel-powered components on this particular design.
Correct,
We
yeah.
have heard of other cars, other battery electric designs that feature other components that use diesel. This design does not.
Mike, what's the total cost here?
So that still is part of commercial negotiations, and I'm bringing the contract possibly next month, and that's when we can have a more robust and transparent
Of an
discussion
estimate?
of the cost. Well, so I'll say this. In the previous presentation that we did for the board, when we estimated the program, the annual operating costs, including the lease, were estimated to be $30 to $35 million a year annually. That is, the operating costs are somewhat offset by no longer running the diesel train. So it's not a completely all-new net cost. So there's some offset in there as well. And then there's the capital cost that you see on this slide for the new facility, the additional infrastructure, and then, as I mentioned before, 9-10 years in to the program, there'll be an additional capital cost for vehicle overhauls.
Thank you. Almost.
Any other questions? Thank you both for good presentation. Thank you.
Thank you.
And good dialogue as well.
Thank you.
That's the final agenda item. Open to a motion to adjourn.
We actually don't need a motion since there's no
don't need a
quorum.
motion.
The meeting's over. So we're all set.
We are all set. The meeting is adjourned.